Welcome back to our channel. Today I've decided to make this video to make you get used to R, to get started with R. I decided to go through some of the things we did in the last videos. We are going to learn about data wrangling, how to draw these plots, how to select data, how to use dplyr to group, and things like that. So at the end of this video, you'll be able to draw these kind of graphs, to use dplyr. You know how you will get familiar with R and the basic concepts of R. So without wasting time, let's begin. We are going to follow this guide. I first make these guides such that we don't waste time. So let's begin by creating our markdown. If you can't make our markdown on your RStudio, you can use R script. It does the same thing. I like R markdown because it creates chunks of codes. So you can delete this and we create our own chunks. So you copy these chunks and paste them. So we're going to paste as many as we can because I think today we are going to tackle a lot of things, all things that need you to get started with R. So R is a really simple tool to use in data analysis, but it requires you to first get familiar with it. So we are going to start off by installing this package, NYC flights, meaning New York flights in 2013. So it will give us, this library will give us the data set which has New York flights which happened in 2013. We are also going to use a library called Tidyverse. It has the dplyr package and the ggplot2, which we shall be using. So you can start off by installing this NYC, or if you have it, I will just recall it, library NYC flights. So you can you can paste this run chunk, and it will run only this chunk. That's why I like the markdown. So we are going to use this library. We are going to also use this library of Tidyverse. So we shall recall it library Tidyverse. First of all, let me clear this console. Last time I told you the shortcut to clear everything in the console. If you want to remove one by one, you just say remove. Short form is RM. For example, if you want to remove this data 1, just say remove data 1 and it will take it out. But if you want to remove everything, you say remove list equals ls. That's a short form to clear the environment. So let's load this database, I mean these libraries. So so let's also load this data of flights which comes with NYC flights 13. So this is in an inbuilt database. So you say data is called flights. So if you have your own data, you can load it. I showed you how to set a working directory and how to load the database. So if you don't remember, you come here in files, you click here, you go on and select where you want to put your database. For example, may I have it here where I want to put your working directory, I mean. So for me, I have this, so I can easily set this as my working environment. I mean, working directory, set as working directory. So if I set this as a working directory, everything I do here, all I save here, will come to my working directory. All I can easily load data using this working directory. So let's say if I had data here, it would be easy to load it. You just click on it and it will come. So, and it will tell you either to load or anything. So that's the importance of a working directory. So if you have data in your working directory, you can easily load it and you use that. But for this tutorial, we are going to use this flight since it comes with a package and everyone can have it, can get it. So we're going to recall this data. If you want to run a chunk, you click this. If you want only to run this line of command, you put a cursor in that line of command and you press Ctrl Enter. For those who are having Windows, I think for Mac is Command Enter. So if you press Ctrl Enter, the flights database will come in our environment. So if you want to view, you can simply type flights and Ctrl Enter, and it will come here. So you will have to, then you can see how your data set looks like. But in order to have a simple view of your data set, you can just say head to look at the first few rows and columns. Head flights, maybe the first 5, the first 5 rows. These are the first 5 rows. So you want to look at it that we have a year, month, delay, departure time, scheduled departure time, delay, arrival time, we have career, the flight. So this is all the kind of data that we have. So we can look at where it ends by typing tail. I think whatever has a head must have a tail somewhere. So tail, you get the last 5 rows of this database. So this is how we quickly view our data set. If you want to, you can also get column names. This is very important to know the column names. Flight. Remember, I'm using Ctrl Enter. It is flights, not flight. So these are the column names, all the variables in this database, or this data set. The year, month, day, departure time, scheduled departure time, delay, departure delay, arrival time. So you can also, these are column names. You can also know the number of rows that you have in row flights. We have, there are many rows. And the number of columns in col. There are 19 columns. So we shall not use all the columns, the 19 columns. in this example. So let's select some variables. Let's learn how to select some variables or some columns. So by this we are going to use the dplyr package, the tidyverse, which is in tidyverse. So we are going to create a new data set, which is called, we shall name data1. And this data1, we are going to select. So this percentage greater than percentage is called a pipe. This pipe connects commands in dplyr. So we are going to select. So you see that we are creating a new database or a data set, and this data set is being created from the data set called flights. And these flights, we are selecting the number of the column names that we want. So let's go back to column names and we see the column names that we want. What did I use? I used year, month, departure time, schedule time, delay, arrival time. So I'm going to use the year. You can just copy and paste. Some variables have their base. So month, if you don't want to mess with spelling. Departure time. Did I select departure delay? Departure time, scheduled departure time, departure delay, and arrival time. So we have departure delay. I'm just copying and pasting, Ctrl C, Ctrl V. Then departure time, departure delay, arrival time. What else? Arrival time. I think that's scheduled departure time. So we also have scheduled departure. Is it scheduled? Yeah, scheduled departure time. So we have created, you see it is here in our environment, we have created a new. We have selected 6 variables and we have created a new data set with 6 variables. If you want to view it, you can just say data1, press Ctrl Enter, and you will see it. This is our data set, the first 10 rows of our data set we have created. So if we want, what else? That is how to select a variable. So we can also have, we can also remove a variable. For example, if we don't want the arrival time, we can create a new data set called data2, and we remove the arrival time. So you don't have to be creating these new data sets. But the good thing with R, you can just be creating these things. So you realize now we are removing from this one we have created, which is data1. We pipe percentage greater than percentage. It's called a pipe. So we still use select, and this select we are removing, it's a minus. We are removing arrival time. Copy that and paste it. Enter. So let's see what is in data2. See, arrival time is gone, and we have 5 variables in data2. The reason why we create new data sets, and you could just say data1 equals, just say data1 equals data1, and you format within this data set. But you want to keep the original data set in case you need something from it. So that's why we create new data sets, and that's an important thing with R. With R. So you have learned how to remove the data set. Let's go on and we filter. So we are going to filter to filter out is like filtering, you know, like a funnel. You filter something that you want, or you filter out what you don't want. So we're going to create a new data set, and we shall filter out month 9. So month 9 is, what is month 9? Is it September? Yeah, September. That's my birth month. Okay, we can create a new data set, data 3. And we are going to create it from data set 2. So we pipe and we say filter. So we are going to filter out a month which we don't want September. So if we don't want September, we use this. If we wanted only September, we would use month equals to 9, because these months, let me show you again. We see these months are in 1, 2, 3, 4, 5. They are not named, so that's why I'm saying is equal to 9. So if we want to have a data set that only has month 9, we could use this. Let's try out and we see. So let's view data 3. So we only have month 9, but I don't want month 9. I want to remove month 9 from the data set. I'll just go back and remove it. And it won't have month 9, even if you say tail data 3. You see, we don't have month 9. So let's go ahead. We have learned how to filter. So the next thing in filtering, we want, if we want to filter 2 months or 2 or more months, and we want maybe 2 months, January and Feb. So if you want to get January and Feb, we use what we call concatenation, that C. If you want to select more than one thing in R, we use that C. Concatenation. Is it called concatenation? Yes. So that C means you are selecting more than one. So we are going to select this from dataset 2. Remember, because this one doesn't have month 9, so let's select from dataset 2. So we shall have data 3. We can still call it data 3. So if you call it data 3, it will replace this one. So be aware of that. We pipe, then filter, month equals C. We want January and Feb. Okay, I want to show you something. Yes. So you see it has brought an error, and I wanted you to show you this. So if you say month is equal to, it will bring you an error. You have to use the equivalent sign, which is a double equals. So with that, it means the month which is equivalent to January and February, not equals. I think we have learned that. So don't get that error and you start panicking. So data 3, if we view data 3, we shall have, okay, that's the head. So let's look at the tail. Last 5 columns, we have month 1 and month 2. So that's how to select month 1 and month 2. You can go ahead and select. That's how we select from a data set. If you want to select specific, you have to. If you want to filter something specific within a variable. So we have selected month 1 and month 2 from the variable month. We use the filter function. So that's the filter function. The filter function can go ahead and do other functions. So let's look at how this data looks like. So we have, okay, this is the tail. Let's have the head. So we can have delay, delayed by 2 minutes, departure delay 2 minutes, 2 minutes. So we can select this, that month 1 and month 2, and they had the departure delay of 2 and had departure delay of 2. Yes. So with filter, you realize we put, even if it is a number, we have to put this quotation. If you don't put quotation with the filter, it will reject it. So if we go back and check the head, we shall only have delay of 2. Because we have filtered month 1 and 2 and the delay of 2. So that's within the data 3. You can also come here and click on it to view it separately. So you see we selected only these variables. We have selected month 1 and month 2, and the delay will be only 2. Even if you load it down, delay will still be 2 and month will be 1 and 2. So that's how we filter and select from a variable. So we select from a data set and we filter within a variable. So let's go ahead and look at another concept, which is so if we summarize, let's summarize departure time. I want to show you how we can get the mean, median, and everything. So let's summarize departure time. So you just say summary. We are summarizing from, I think, data 2. It's the one which is not so disturbed. And did I set departure time? Yes. So you see the mean is 13, the median is 1401, first quartile is 902, minimum is 1, maximum is 2400. Oh, this one delayed a lot. And then any A's, all these which are not filled, the missings are many, 8255. So we can decide to filter if departure time is greater than the mean. So if we want to filter from, data set 2. So I can also show you that we can run without, if you just want to visualize without saving into data sets, you can just type and visualize. So if filter is it departure dinner? Yes, departure time is greater than the mean, which mean is means is 349. If we are using the greater sign or less than or greater or equal to, you don't have to put in quotes. So let's run this and see. So if you run this, it will just show you the table, so, but without storing the data. So this data set 2 is not changed because we haven't stored anything. So we are just viewing within. That's why also another thing why I want this markdown. So you just view within. So we have, you see, if everything, the departure time is all greater than the mean 1349. You see it starts from 1350. So if you want to always select these people who had a departure time greater than mean, you can store this into another data set. Maybe data 4. No, it said delayed. Maybe delayed. So if we do that, then we have stored the the data set. So the data set, we have stored data set for all those that it delayed. And you see the total observations have changed from 33. So these ones are 168,239. So the observations have changed because we have already selected those which are greater than the mean. So that's one way to filter by mean, or you can also filter by the median. So that's it. So let's learn how to use the mutate function. Mutate, as you hear it, I think we have had it a lot in COVID-19 as the virus mutates. So it means the virus changes its shape. So here we also, if we are to mutate, we change the shape of the data set. Or we change something within the data set. Let's mutate. So in the function mutate, let's learn how to rename, or we are going to rename our months. We saw they were named 1, 2, 3, 4, and so on. So we are going to learn how to rename the months, and using the dplyr function. This rename, we are going to use the mutate function in the dplyr. So we are going to say data 4. We are going to store it into data set 4, and we are going to use the data set 2 because it's the one which we haven't changed so much. So we use the pipe, and this pipe we are going to mutate. We're going to mutate this data set and store it into data set 4. But our mutate is going to be, we said, we're going to mutate months. And month is, so by mutating month, we are going to create data labels. Data labels are going to be from January to December. And we see we are going to use the factor function. We want to use the factor function because factor means a categorical variable. These are categories, so they are in they are categories of months. So we're going to use the category the factor, and this factor we are factoring this same variable month. And now we are going to use the labels. We are going to give the labels. So these labels are many, and we said if something is many, we use the C. And C comes with its brackets because you are concatenating everything in that bracket. So this is not a difficult command. So we are mutating math, and this math we are giving it factors. It is a factor variable, and it's this factor variable math we are giving it labels. And these labels are going to be January to December. So in order not to waste time, I'm going to just copy these labels inside January to December. So you separate these labels, all these you separate them with a comma. So let's run this. So data 4, you see we have now renamed January. if you want to summarize, don't know if month summary data for a month. Let's see. Oh, could not. Oh no, this is the wrong spelling. So you see we have January, February, March, and it gives you the total numbers in every month. January, February, March up to December. So that's how we can know that we have all the months from Jan to December. So now we are going to use the if-else command. This if-else command helps us to also categorize. The categorize, like for example, if we are categorizing the numerical variable or continuous variable, if also we want to rename. So if we want to rename, maybe if we had two variables which are to be renamed, we shall see how to use this if-else. So this if-else statement, A is the condition that you want to use if-else on. B, if that condition is true, what do you do? And else, if that condition is false, what do you do? Let's see. So I want to create a variable called delayed category. I'll store it in data 5. Now I'm going to start using data 4 because I've renamed these months. So we are still mutating. We are mutating data 4, and we are going to create a category called delayed category. And this delayed category, let's say that everyone who came greater than the mean departure time, let's say they delayed, and those who came less than the departure time, let's say they are not delayed. We're just creating a category, two categories between departure time. We know our mean, we saw our mean was 1349. So I want to create this delay category using the if-else statement. So this will be if-else statement, if-else. So remember we said the first is the condition. The first is the condition. So the condition is going to be if departure time is greater than the mean, which is 1349. Was it? Yeah, 1349. Yeah, it was 1349. Comma, B is if this condition is true, what do you want to do? I want to rename that thing, all those people, as delayed. So the third condition is else. If else, what do we do? So else, there are only two categories, greater or below. If they are greater, they are delayed. If they are not, else, let's say not delayed. Let's run this. Let's look at our data 5. Oh no. Okay. So you see we have created two categories of delayed and not delayed. We can get a summary. Data 5. Delayed category. So, okay. It has just given us the length. It doesn't. So you see it has just given us the length of a character because it has not considered it as a factor. So let me include this. Now I don't know if this will work. Okay, yes. So if I included the factor to make it as a categorical variable, it has given us the values as delayed or non-delayed. So R has a tendency of not understanding categorical variable unless you tell it that you treat this as a categorical variable. If you don't, then since we didn't give labels to this, so that's why label values, that's why it's not considering it as a factor variable. So the missings are many. Not delayed are these, and these which are delayed are these. So you can still use the mutate function. Let me show you. So if we have data 5, we have data 5. Mutate. So we're going to mutate the delayed cut. All right. So we're going to mutate the delayed cut. Oh, we're going to create a new variable. Let's call it delete2. We're going to create if-else statement. So this if-else statement, if the delayed, we're going to say delayed 2, the condition is in the delay cut, comma, we're going to so I wanted to rename this either delayed, but I seem not to find another suitable word to use. So those who are greater than this delayed, those who are less, they are not delayed. So I wanted to show you how you can also rename this, maybe to another word, which I can't find a suitable word to substitute with delayed and non-delayed. Okay, let's leave that. You've gotten the idea of if-else. So let's move on to, so what if I want to categorize this departure time? What do I do? So if this will lead us on how we can rename the categories. Still. Okay, we are going to store, we are going to mutate, first of all, we are going to summarize our, is it still, yeah, departure time. So we still have our departure time somewhere, the summary. Where's the summary? Okay, let's do it again, no problem. So let's get a summary of our departure time from data 5. So we want to create categories from 0 to the first quarter, from first quarter to median, from median to maybe third quarter, from third quarter to the maximum. So the values will be for minimum, which is 1, 2 through 907 through 1401, 17, and this. So in order to create those categories, still we are going to use the mutate. We're going to use the mutate function, command. But first, we are going to create sections by using this cut command. So you're going to create sections in this data set. So you realize that, okay, I'm going to show you. So we are going to create a new variable on dataset 5. So if you are to create a new variable, you just add it. So we are going to create a new variable using this $, sign. We're going to create a new variable called delayed delayed category 2. So we are going to see how many delayed between 1 and 907, between this and this, between that and that. So we are going to create, this means we are adding, because this variable is not there on data 5, we are just adding it, and we are adding it on, so we're going to cut. So we are cutting departure time. We are cutting departure time, don't forget that. So we are going to cut departure time. So to select data, we are going to cut departure time from dataset 5. Dataset 5, oh, what is happening? Okay, we are cutting departure time. And we are cutting departure time into many factors. So let's look at from 1 to 907 to 1401, then to 1744, then from 1744 to 2400. So we are cutting through these categories. If you don't know the mean, I mean the minimum, you can start from 0, but I know the minimum now and the maximum. So we are cutting, we have created a new variable on data 5. If you want to see it, you just type data 5. We have created a new category, which is category 2. From 1 to this, you could see also from 907 to 1408. If we summarize, let's get a summary of, okay, it is a factor, it's a factor of data 5, category 2. So we have, okay, now I see. So it doesn't query, it has made it as a factor, but the numbers. So in order to prevent this, we are going to give them labels. These labels, remember, Chu1 is from the lower quartile. Okay. Yes. Chu1 is the lower quartile. Chu2 is the median. Chu3 is the upper quartile. And maybe we can say Chu4, which is the maximum, or you can just put max. So we're going to give them names, and by giving them names, we are going to use the mutate function, and it will be data 5. Yeah, still we are storing data 5 is equal to data 5. We are mutating the same data set. I don't want to create a new data set. So mutate. So we are mutating by creating variables of delayed cut2 is equal to factor. So now let's give it factor name, I mean a factor value. So we said, and that factor is going to be in a delayed category 2. So the labels are going to be 1, we're going to say Chu1. The second is going to be Chu2. And the third is going to be Chu3. And from Chu3 to the maximum, let's call it Chu4. Press enter. Control Enter. So let's look at our, so you see it has renamed Q1, Q2, Q3. So let's summarize. Because we have named it as a factor now, we can just say summary, delete the cat 2 without putting the factor thing. You see, Q1, Q2, Q3, Q4. It has given them the values and the NAs. The NAs are so many. So those are the missings. So we can delete the missings, but we can leave them now. So that's how we create categories from a continuous variable. So we can still, if we wanted maybe to draw a bar graph of these categories, we can draw it. So we can, if you want to put to draw a bar graph from these categories, first we are going to draw a table. This table, only table to show the frequency, these frequencies. From this table, then we shall be able to draw the bar graph. So the table, we can call it table 1, tab 1 is equal to, okay, let me first set table. So I want to show you something before I introduce the data frame. So this is the rate. We are looking at data 5. Is it data 5? Yes, data 5. And we are looking at the category 2. So it has created the table 5, I mean table 1. So if I show you table 1, okay, there's something I want to show you. So this is the table 1. And when you look at table 1 here, it is a vector. So it's not in a data frame format. So if you want to put it in a data frame format, you just add data dot frame. Just put everything in brackets here, data dot frame. So now if you press table 1, it will show you in the data frame format the variable and its frequency. So as it was here, I think now we get the point. So but I don't want this to be val1. I want to rename this. Maybe I can leave frequency, or we can put count, but I want to rename this. So in order to rename that variable, we say column names, and from the column names we want from tab 1, but we want the first column. To select the first column, you select it with the square brackets, and you want to rename it to, you want to rename that column to, what do we call that now? What did I name it? I named it as ranges, maybe. There are ranges, from range this to range this. So it is a word, so we shall put quotes, ranges. Let's also rename this column, the second column, tab 1. Let's select column 2. Let's name it to count, rename it to count. So if you say tab 1 again, we shall see that we have renamed to ranges and count into this data frame. Now tab 1 is no longer a table, it's a data frame. But a data frame from a table, the table which only contains delayed category from data 5. So now if you want to draw a bar graph, let me see if that's what we are going to do next. Yeah, if you want to draw a bar graph of these frequencies, we shall use what we call a ggplot. Now, a ggplot, this ggplot is from ggplot2 package, which is in the tidyverse. And ggplot, I will go through ggplot in another episode in depth, but now I want to give you a summary of it. So it has the ggplot, which is the first command, and the first command, you input what you want. You input the data, and it has what we call asterisks, which is short form is AES. So in that AES, you put what you want, what you want from that graph. What do you want from that graph? What do you want from this data, which is tab 1? So data tab 1, we want X variable as ranges and Y variable as count. That is 1. So now the next part is for the geom. So the geom, or the geometry. So what's the geometry of this graph? So the geometry of this graph is going to be a bar graph. That's why we have geom bar. So then what is next? We want to start equals identity. So these are the things that are in geom bar. We want to fill these columns. Fill means a color. You have to fill them with red, green, blue, and maroon. So let's do that first. I'm going to just copy because, okay, maybe I can just type it, but it's too long. So we're going to have a ggplot. You can also store this graph into maybe P1, plot 1, but I don't want to store this graph. So you are going to say ggplot1 is equal to, oh no, ggplot data equals tab 1, or you can just say tab 1, then comma, the ES, the asterisks, we have our X variable as ranges. We want to select ranges from as X variable. Then the Y variable is going to be the count. Count. Remind about the spelling. Count is capital T. I mean capital C. So what next? What's the geometry of this plot that you are going to do? I want the geometry, which is geom, to be a bar. So inside this bar, what do you want from this bar, which is the start, and it's going to be identity. It means you're not changing anything. So starts identity, and I want to fill, I mean to color my bar graphs. Since they are 4 from Q1 to Q4, I want to color them with a different line. Or you can just not put a color of your choice. It will choose for your color, but for me I want to choose. So fill equals, I want to fill. C, concatenation, means you are selecting more than one. So the first is going to be red. Don't mind about my color choices. Maroon. Let's use small letters. Red, maroon, black. I'm just thinking about colors, don't mind. Then orange. I hope it will look good. So then after that, you can stop here and look at the graph. Oh no. So my color choices are bad. So this is a graph of a count of these ranges and the colors, I mean the ranges versus the counts, you see that they are all nearly the same because these values are almost the same. 221, 222, 228, 222, 820. They are almost the same. If they were maybe this one 600, this one 800, this is 400, they would be different. I think my color choice isn't that bad. So if we want to, again, you can stop here, but we want to put maybe the title, we want to change this, we want to change the theme, the background of the graph. So that's where we go to the next. You just add on. You know, there are so many which you can add on this graph. So we can add on the theme. The theme, and that theme, let's add on the theme, or plus theme. So you can add theme classic, theme blue, which is its loss. So this theme removes the background and that puts graphs. Let's look at another theme. It's a theme classic. Theme classic makes it a white background. Okay, let's stick with theme classic. Now let's add labels, and we call them labs for ggplot. So the labs are going to be in quotation. We start with the title, is it? You can start with anything. So we're going to rename the title. You can start with x-axis, maybe x-axis. What's the x-axis? You can leave the x-axis. It's ranges. The y-axis. Maybe number of hours, and title maybe a bar graph showing blah blah blah, the categories. So you see that we have built this graph by just adding on what. You can also add on numbers here. So there is a lot you can just add on. That's a good thing with ggplot. So you see we have added our title. They renamed the y-axis, the x-axis. So let's see what next. What did we do next? Oh, we created another table. Oh, wow. Okay. I'm going to skip this. I'm going to skip this unless it looked nice. Let me see if it looked nice. Oh. Okay. I understand. So we're going to add... let me show you how to add this. What we call geom text. Geom text, we are going to, it means these numbers. Let's say if I want to add the specific numbers here, I'll add geom text. So I'll cover another topic of ggplot. So I'm just giving you an overview. So geom text has also the aesthetics, and in that we want to, what do we want in these aesthetics? We want to put maybe numbers here. So those numbers we want, they are called labels. So the labels that we want to put, they are frequencies of these. They are frequencies of these bars. So the label is going to be frequency. What else do we want? So we want to these frequency. Let me just put them and you see. What did I change? Okay, and change the frequency to count, so you have to be mindful of that. So the labels are going to be for count, but you see if I left it like this, they are within, they are cut forward, they don't look nice. So let's make some adjustment. So the h just, that is the height, let's put it at 0.5, and the v just, oh yeah, our h just is the horizontal justification, it's going to be 0.5, which is halfway, and the vertical, let's put it at -2. Oh, where have they gone? Inside. Oh, negative. No. Positive. Oh, again. They are inside now. And you see this one is not. You can even give a color. Maybe we give them color white. Is it? Let's see if we can color them. Color equals white. Yeah, we can give the colors, but you see we now just have another thing here, which doesn't make sense. So let's remove the color. Let's just adjust our height, h just. So what did I use here? -0.2. Just to be just above the graph. Yeah. So this is how we put these frequencies above the graph. You just have to adjust these numbers. So for this case, the negative puts it up, the positive sinks it down. So puts it down. So what next? What do we have next? So we're going to skip this. I wanted to show how to get this. So let's create another table. Oh, okay. This is going to be interesting. So let's create another table. So we can create a table of three columns. Maybe if you want the month, the delayed category, and the count. You can still do that. Create a table of 3 categories. But now let's look at how to use group by. So we're going to use group by command in dplyr. It means you are grouping this data according to the variable that you want. So let's group by the month and summarize departure time as a mean. You're going to call this data 6. Data 6 is going to be we're going to get it from data 5. So percentage greater than percentage. We're going to use the group by. You're going to group by month. Then summarize. That's how the pipe helps. The pipe connects commands. So we can connect the group by and summarize. So we're going to summarize the departure time as a mean. So we are going to summarize this departure time. So we are going to add another command, percentage greater than percentage. You can here add a filter, what? So let's summarize now. Summarize. So summarize is a dplyr command. It is not the same as summary. So we are summarizing, but with this summarizing, we are creating a new variable called maybe mini departure time. Let's call it average departure time. Departure time. Average departure time is equal to the mean of the departure time. Dep time. I want to show you something now. So let's look at data 6. So you see we have NAs throughout as the average departure time because our data had a lot of missings. There were many, that's why it has shown a lot this average departure time as NA. So remember, we are summarizing, we are grouping by month, and we are summarizing in each month we want the mean departure time. So you can just draw a bar graph of mean departure time for every month. So in order to remove that, let's say n.na.remove equals true. Let's remove the NAs. So after removing the NAs, so we have the mean departure time in each category. So the mean departure time in January was 13.47 something. It was almost the same as Feb. By the way, these planes keep time. That's why you see that these delays. Okay, no, that doesn't happen. Yeah, I would say some airline, but let me just forgive it. You see that the mean departure times are almost the same. So let's draw a table, maybe a bar graph of. So let's draw a bar graph of mean departure time versus the months. In each month, we are going to draw a bar graph of the mean departure time. So we can store that plot maybe as a PL, and we are going to use ggplot, and in the ggplot we are using data 6, data equals data 6, comma, the asterisks we are going to use, x is going to be our month, and y variable is going to be the average departure time. So let's add a geom. The geom is going to be bar, and the asterisks in geom, we are going to have start is equal to identity, so let's not fill this because these are many. Let's first draw this. So let's first print this graph, and we see, since we have stored it, we're going to use the print command. So by printing this, oh, there is an error here. So the error here has to, let's see what it says. the error is in the asterisks or start count. So geom bar doesn't have the asterisks. Let's remove them. And by removing them, we take off one. So yeah. So you see it has printed. You see the mean average departure time is almost the same. That's why they are also almost the same. So we can position this, maybe position equals dodge. Oh, that's the spelling of dodge. So we can say the position dodge. Let's print this graph. So you see that we can use fill for this. We can use the fill per month. Let me try it. Fill equals month. Oh, okay. Sorry about that. Oh, still it has refused to fill by month. Okay, let's do this and we see. Okay, here they don't look nice, so let's add a color, and we're going to fill by month, such that we don't want to create color for each. So you see it has created its colors of choice. So maybe we can add labs, which are the labels, and the title equals, let's just say bar graph of months versus average departure time. Then the X is going to be the months. Y is going to be the average departure time. So you can see I'll add another label for colors because it has created it here. So that label is going to be called fill. So the label for fill is going to be months. So you could okay. So let's run this and we see. Yeah, it's now clear. So this is how you can draw bar graphs from the data that you have from the dataset. All bar graph from the average departure time for in specific months. So let's go ahead. So the way to export this this graph, you can just right click and save the graph. To show you where to save it, and okay, you could save it like that. All the reason why I give it a name is when I want to save it. So when you go here in the console and you press PL, the name of the graph, it will come in the side window. So here you can save as a PDF, PNG. PNG is the best format of a picture, doesn't change its pixels. So you just give it a name, maybe graph 1. So if you want to send this graph to someone or to anyone, or to copy it into Microsoft Word, you can still go the other side and copy it, because it will have the same resolution. It is better than copying it from here. So let's look at another concept, probably the last concept. It's not the last. So how to draw maybe another graph of maybe a scatter plot. So to draw a scatter plot, we shall use still the ggplot, and this time data we are going to use still data 6. Is it? Or data 5? I think data 5 is not so modified. So the AES, or the aesthetics, we are going to say X, since it is a scatter plot, it has to be between two independent, let's look, it is going to be between two continuous variables. Let's look at data 5, how data 5 looks like. So data 5, we're going to scatter departure time versus the scheduled. So we're going to scatter between departure time and the scheduled departure time. And we see the difference, how these two display. So we're going to, it's going to be departure. I think it's called depth time. And the Y is going to be the scheduled. Y is going to be the shared depth time. Shared, mind about the spelling. Depth time. So this time the geom is going to be point, and the geom point has asterisk this, which is AES, and we can put here color. We are going to color this by, let's separate those who delayed and those who did not delay, maybe by delayed category 2. Delayed category 2. So let's scatter this and we see. So it's taking time. This is a very big data set. Finally it's here. So it has colored, it has put the dots here. You can even change the shape of these dots. You can just add in the aesthetics, like shape this, but now we can still shape. It's okay. We can shape by departure, delayed. So it's shape by delayed, and we see. Yes, it has created new shapes for each category. So you see that they are within almost the same, because the departure time almost coincides with the scheduled departure time. So it has removed the missings, which is a good thing. So this is how we draw a scatter plot. You can go ahead and add labels and everything. So you can do that as in your own time. So we're going to look at one last thing, and it's going to be, we're going to use in. So in also works as a filter, but it filters within a category. So let's say we are going to filter month. For month, we are going to filter in January, and within January we want the delayed category, which is not delayed. and we are going to group by the delayed category and summarize those frequencies, those numbers. I don't know if I'm making sense, but when I start, the sense will come. So we're going to create data 7, and we're going to get it from data 6. We are going to filter. What are we filtering? We are going to filter. We are going to filter data 5. In math, we are going to filter January. So you see here, I use the data within the filter command, or it can be outside, no problem. So we're going to filter January. Is it? We want to filter month. And this month is going to be, in the month we are going to filter, we're going to select January. So in month, we are going to select January. Mind about the spelling. Oh, this is a small c. We are going to select January, and in this January, we are going only to, within January, let's get only those who did not delay. So that means the delay cut, from the delay cut, which is within the January month, in data set 5, we are going only to select those who are not delayed. So, comma. So within this month, we are going to also, we said we are going to select from delayed category, we are going to select those who are not delayed. So from the delayed category, now I have delay cut in dataset 6. Let me first look at dataset 6. I might be using a wrong dataset. No, I'm using a wrong dataset. So let me see. I'm supposed to use dataset 5. Okay, because it wasn't coming out. That's how I knew. So when you pipe in here, when you start to type, it will show you the variables that are there. So we are going to select again those who not delayed. So, but what do we want from them? We want to group them by delayed category 2. Okay, this is going to be interesting. Percentage greater than percentage, group by. We are grouping by delayed category 2. Delayed. Oh no. Delayed category 2. And within delayed category 2, we want to summarize the frequency or the count in each. So let's summarize the frequency. Let's get the frequency in each. Summarize. Summarize frequency equals n. So we are going to summarize the number, which is the frequency. Let's run this command. So let's look at the data. That data set 7. 0. We don't have anyone there. Let me look at it. It has the delayed category 2. Oh no, I think there was nobody not delayed. So let's remove this group by, is it? I think from January. Let's add Feb and we see. No, December. Still 0. There was nobody who was, there's no plane which was delayed in December. Okay. So let's remove this group by and just summarize. Oh, this is interesting. Oh, okay, sorry. Oh, still no, none. Yeah, I think there wasn't. That was delayed, which is a good thing if there wasn't. So, but that's this was just to show you how to use the in from within the months of January and Feb. Pick those delayed categories, and from the day, I hope I didn't make wrong spelling. Not delayed. Yeah, it's the spelling. It is a small d. Oh, that means I was correct. There should be, yeah, there should be there. Yeah, we are looking at Jan and December. Maybe I spot back our, and we see our group by. So group by, delayed category 2, and summarize by frequency equals n. Yeah, we see Q1, Q2. Only in Q1 and Q2, that's where we had the category 2, which were not delayed and were from January and December. Oh wow. So if we don't use the group by, let's say we skip the group by, let me just copy this and paste it here. Maybe data, we can leave it data set 7. So if we remove this group by and we just summarize. Oh wait, what is not happening? Okay, another bracket, sorry. No, non-delayed. So there's nothing there. So let's just leave it at that. Maybe we wanted to summarize January and December. We wanted to just summarize January and December, and yeah, and select only those from January and December. From months, select only January and December, and within January and December, only select those who are not delayed. So this is what it did, and you see how data wrangling in R is interesting. So within these months in dataset 5, we are selecting within months of January and December, and within months of January and December again we are selecting only those planes that delayed. So if we change this to planes that did not delay, oh, not if we select which planes are delayed, it will change. It will give us only the planes that are delayed in January and December. OR is very interesting. So I think this was a nice introductory video to R, and don't forget to subscribe. It really means a lot to us. And put the like button. Push the like button. You can also suggest the topics you want us to discuss next. Thank you for listening.